And I would like to invite to the stage our first speaker. She's Andréia Costa, a PhD student at the University Medical Center in Groningen, at the University of Groningen in the Netherlands. So please, Andréia, the floor is yours for your first international talk. So good luck with that.
Thank you very much for the nice presentation. So I will present now the study entitled The Effects of Cognitive and Mechanical Constraints on Modular Neuromuscular Control in Younger and Older Adults During Being Walking. This is a study with international collaboration of the University of São Paulo in Brazil and also the University of Illinois at Chicago. So it's broadly accepted that the central nervous system has to manage multiple degrees of freedom to produce a well-coordinated motion. In this way, it's very one of the recruitment of synergies is a good example of how the central nervous system can take advantages of the modular control. Here we are taking muscle synergies as group of coactivity muscles that can be flexible, recruited to convert movement goals into task-specific biomechanical outputs. The manipulation of cognitive and mechanical constraints can affect performance of walking and also spatiotemporal parameters of gait, as step speed, step length, or step width. The role of the arms during walking is very important because they have to counterbalance the leg movements. And while more challenging tasks, as this in the video, or as being walking, the legs can also ensure the stability by shifting the center of mass position. Regarding of cognitive constraints, we already know that older people has a more a less automatic and are more dependent on brain areas responsible for vestibular system, visual system, and also sensorimotor system, while young persons has a more automatic gait, being dependent only on visual brain areas. However, we don't know if these constraints can also affect the neuromuscular control of gait, and if age can mediate these effects and how. In this way, our aim here is to examine the effects of cognitive tasks and changes in arm position during being walking in modular control of younger and older adults. We expect that the more challenging conditions, as higher cognitive load and restriction in arms, will increase complexity with higher number of synergy and lower variability account for by the first synergy. Also increase the coactivity with more significantly active muscles recruited per synergy, and also increase the efficiency with the sum of the activation of these active muscles per synergy. On the other hand, the age, we expect that it will decrease complexity and efficiency of neuromuscular control, but not coactivity that should be greater in older adults. So we had two groups. The younger group was formed by 17 persons with 24 years average, while the older adults group was formed by 14 people with 69 years average. They performed two blocks of being walking. So the beam has 6 centimeters wide, 2 centimeters high, and 4 meters long. And the first block was performed without the cognitive task, and the second block with the cognitive task. The cognitive task was sequential subtractions by 3, starting in a number between 300 and 900. Within each block, the arms were totally randomized between 3 arms, as we can see in the video in the left, and cross arms, as we can see in the video in the right. So they performed 40 trials in total, being 10 trials for each condition. We used non-negative matrix factorization to extract the muscle synergies of 13 muscles from the right leg and trunk. And then we analyzed the complexity, the coactivity, and the efficiency of the muscle synergies. The complexity was assessed by the numbers of synergies recruited and also by the variability accounted for by the first synergy. Coactivity was assessed by the number of significant active muscles per synergy. Here we are going to call as Wmus. And efficiency was assessed by the sum of the activation of these active muscles per synergy. Here we are going to call as Wsum. We saw that mechanical restriction, so the restriction in the arms, increased the variability accounted for by the first synergy. But these results we could just see in older group, in the older adults group, suggesting that this group has less complexity while performing the beam walking with crossed arms. The cognitive load increased the Wmus. This is the number of significantly active muscles per synergy, but this result was seen just in the younger adults group, suggesting that this group has more coactivity in the presence of the cognitive task. The age showed less number of synergies for older adults and also higher values for variability accounted for by the first synergy. These two variables together imply in less complexity in older adults group. We also saw higher value of the Wsum. This is the sum of the activation of muscles per synergy, implying that older adults has less efficiency in their neuromuscular control. So what can we discuss about it is that the cognitive task increased the coactivation in younger adults, what goes against what we already had in the literature, because the literature always find that increase the coactivation in older adults, especially during higher cognitive load, but we can suggest that our younger group could shift their neuro control from feedback to feed forward to be able to guarantee safety during the motor task while they can focus on the cognitive task. Regarding the restriction in arms movement, it decreased the complexity in the older adults, which again goes to go against to the literature, as in literature we have more complexity in more difficult tasks. So if we have cross arms, it would be a more difficult task, and we expected to see more complexity. However, when we have the arms crossed, the central nervous system has to deal with less degrees of freedom and has to produce less biomechanical outputs. So this can explain how why the complexity is lesser in this condition. However, we have to pay attention to the high variability we had in both variables. And this can be one of the reasons that we just saw the differences in just one group and not in both groups in each variable. Regarding age, we have that age decrease the complexity and efficiency of neuromuscular control, and it agrees with the literature and with our previous study. And we suggest that older adults do that to preserve motor performance and safety during being walking. However, the number of synergy decreased in older adults, and in literature, we usually see that it remains the same across all lifespan, just changing with pathology or fall history. So it disagrees with the literature. And about the efficiency, we agree with the literature, seeing that it can be degraded in individuals with sensorimotor impairments. This is the cases of older adults. And we always also saw that aging process can affect also factors needed to, for a good neuromuscular efficiency, as use of cortical resources or generation of neuronal activity in primary motor cortex. So in conclusion, we have that cognitive and mechanical constraints affect neuromuscular control in different ways based on age, increasing the coactivity in younger adults and decreasing complexity in older adults. And age per se also affect the modular control strategy, showing less complexity and less efficiency in older adults. And I want to thank you for attention. This is my email for contact. And I also thanks FAPESP for the financial support. That's it.
Thank you very much, Andréia. Congratulations, very interesting talk. And we have one question from JJ. In your first slides of the results, did you test for the interaction between group and complexity? He points out that it's not right to say it's significant for one and not for the other. And he suggests to, he or she suggests to need to test for interaction, and also put a reference that I can also copy in the chat. And he concludes saying that it's an excellent job for a first international talk, and I agree with that.
Thank you very much for the compliments. And yes, we tested for interaction as well, but we didn't find any interactions. Actually, we run the analysis with the age as covariate, and this was the results we had, but no interaction was found.
Perfect, thank you. And I have a question myself. I didn't get the method that you used to extract synergy. So was it non-negative matrix factorization or something?
Yes.
Something else? Okay.
Non-negative matrix factorization, yeah.
Okay, that's what I was expecting. Okay, thank you very much, Andréia. Thank you very much. And so I think we can continue with our